Hey guys, welcome back to this channel. I know it's been a super long while since I've uploaded something, but I was exploring some things with Nuxt recently in terms of data fetching, the composables like useNuxtData and just some other data fetching related things. And I thought maybe I should make a video about this because it's quite interesting. Usually when we deal with state, we tend to just install Pinia or just use like a state management thing to do everything globally. But recently I had to work with a very large data set and sort of render out a big table with lots of data. And I did notice like on lower end devices, it just doesn't do very well. And I decided to dive into why. So I thought I'm just going to go off the top of the dome and just go through everything I discovered. It's not a very formal video. It's not going to be your favorite creators type of video. It's just me riffing everything that I have discovered. So let's have a look. Okay, so firstly, let me explain what's happening. I've set up a little test server. I'm gonna go in there just to show you quickly. Let's just make this a little bigger so that you can read what's up. So it's just a little bun server using H3, and there's two routes. The one is just get the base route, which is post with comments, and that's just a massive 4,000 line JSON file that has fake posts, and each post has comments. So it's a lot of data being pulled in at the same time or at once. And then there's another route, which is basically just get a post by ID, and we fake it by adding a sleep so that we can sort of simulate a slow network request. And if we don't find the post, we return an error. Otherwise, we return the post. So that's basically it for this thing. I'm going to start up this server and put it up to the side. And then I'll show you the Nuxt app that we're working with. So let me just fix this up. Right, so the Nuxt app, let's zoom that in as well. The Nuxt app is basically, I have a few branches, so let me show you that first. So we're going to discuss a few things. It's going to be git branch, show me everything. It's caching, main, deep versus shallow, and useNuxtData. So first, let's look at just the base application. Okay, thank you. And then in the base application, we have a pages. This is using Nuxt v4 compatibility mode. So there's already a lot of cool things being done under the hood in version 4 to help with caching and, not duplicate data, but there are some very advanced nitpicky features that we can use without any state management libraries that we can improve our flow. So in the app pages and the index page, basically what we do is we fetch the posts from the Nuxt API, which is basically just a proxy to the H3 API. So basically we have to manually type the post, and then we fetch that from the base route and we return all the posts. And then in the index page, we look at the posts, we render them out in a list, and then we have a Nuxt link to an about page, and that's there for a reason. So I can show you a little bit about the performance stuff that I kind of try to implement. So that's it for this one. So let's go to a terminal and then start up this dev server, and then I'm going to wait for it to start and then refresh this page. We have a 404 because I haven't implemented that. So now you can see very ugly, but it gives you the gist of everything. It's a huge list of posts. And one thing I want to show right off the bat is if you inspect in Nuxt, you can go to the console, or you can use the DevTools, but I just sometimes like doing this. Double underscore, capital letters Nuxt, double underscore, and then data. And there you'll see that we have a strange key over here and a big array of 100 posts, and each post having comments. So you can see that the comments is also an array. And the first thing I want to talk about is basically how the normal way in Nuxt 3, not Nuxt 4, but the current way in Nuxt 3, what happens is when you query with async data like this. The default, I believe, is deep true. I'm not sure if they maybe changed that in the latest one, but usually when you fetch a big list of data, when your list comes in, every single object and every single key in that object gets basically turned into a ref. So if you update your any of those objects, they automatically get updated in the view. That's kind of inefficient. So basically Nuxt is watching every single list item in here and, well, view actually, and making it a ref so that when it updates it, the view re-renders. And that can be quite costly. So let's have a look at another branch called deep versus shallow. So let's go to the terminal. Again, change that up, and then get checkout deep versus shallow, and then run again, and then go back. So now you can see I'm still using deep true over here just to simulate what the normal flow is. And then what I'm going to do is I'm going to update the title when the page mounts. I'm going to update the title of the first item after 2 seconds. So if I refresh this page, you'll see it takes a second to load, and then 2 seconds later the title gets updated because the component or the text re-renders because we are watching the. Now when you set the deep option in use async data to false, what's going to happen is you won't see that your post updates after 2 seconds. Once it mounts, nothing happens. If we look at the Nuxt data and we look at the array of items, you can see that the posts have actually updated. The title is now updated title, but it's not reflected in the render. So one drawback is that the benefit is that you have basically not a bunch of refs on everything and causing view to watch everything to react to changes. But the downside is that you can't manipulate the object in a very specific key and then expect it to re-render. So you might be thinking, okay, well, let's just add the key over here so that it reacts to title changes as well. But that also won't work because there is no reactivity on these nested objects. The thing you have to do, which might seem a little bit counterintuitive, but what you can do is you can store the current posts is going to be the data.value, and we'll just tell it that it actually exists. And then we can say that we can just change the posts at 1 at the first index and tell it that exists too, and say update the title. And then we can change the entire data. So basically we're going to say that data.value is equal to the posts. So that will trigger the reactivity, and my LSP is doing weird things. So we're basically replacing the entire object, and at first you might be thinking like, what, that doesn't seem to be more efficient because you're updating all the data. But if we inspect the elements and look at this first post only, just watch the DOM when I refresh. So if I go up to here, just watch the DOM. It only updates the single DOM element. All the other allies aren't replaced because only this object was changed, and Vue has sort of fine-grained activity or reactivity to know that only this item changed, so only re-render this specific title on this specific item. So swapping out the entire data with itself seems like a big overhead to sort of replace everything, but when it comes to the render cycles, it really doesn't affect it that much, as well as you don't have all these extra refs on everything. So it's a bit of a headache to update something, but it really reduces the amount of reactivity that needs to go on the page. Okay, next up in my explorations, let's check out the caching branch. And there are a few changes that occurred in the caching branch. First of all, in the server, there is a new way of defining the endpoint, which is define cached event handler, which basically gives it a max age of 2 seconds And I'm going to explain why this can be good, but also what the drawbacks are. And this is the old way of doing it. So basically I've added a posts key, which is all the posts, and a rendered ad so that we can see when this has been rendered. And then in the pages, I've updated the index to show the rendered ad. So you can see there's a few options here. We'll check out each one. I'm showing the rendered ad over here. So if I go to the terminal again and just start a new server and refresh this page, let it load up a little bit. I can go back to the pages, and now you'll see that we rendered this at 10:59:44. So should be updated 11:34:26, 11:34:33, 37, 37, 42, 42, 45. So what's happening is it only changes every now and then, and the reason it's changing a little bit too often if we go to the server is because the max age is only 2. So I'm going to change this to 5 to make it a little bit more clear what's happening. If I refresh now, we should see this updated to a new time. So it's 49 now. Refresh again. Refresh again. You'll see it's 04 again. You'll see it's 04 again. And now it's 12. So if we refresh again, it stays 12 for a couple of times. And now it's 19. So it increments only every, let's say, about 5 seconds. And the benefit of this is, so if we go back to the old way of doing it, let's say I comment that out and go back to this and refresh now. You can see it takes a while to load. But the benefit is if I go to the about page and I go back home, it takes about a second for this page to load. So every time I go back home, it sort of lags out. And you could use lazy async data and show a loader instead of immediately showing everything or letting the page lag like that. But what I found is using caching could be a little bit more user-friendly because you basically instantly see the data. And let me show that to you. So now we comment that out and we go back to a cached event handler. If I refresh this, we should have cached data. So I go back and it's instant and it never lags again. And if you look at the time, 36:27, 36, 34, 34, 34, 34, stays 34 until the 5 seconds has elapsed and now it's 41. And it doesn't lag in between there because what Nuxt does is it refreshes it in the background. So once you make your request, it returns the old data and then does a refresh in the background. So you don't have to worry about it ever lagging again when navigating like this. And eventually you'll get fresh data. So that really helps with navigating back and forth between pages. But the drawback to this is that you need to have a backing storage for this. You need to have Vercel KV or Vercel blob storage or something wherever you're hosting. If you're on Cloudflare, you could use R2 or something like that, that basically stores the data until the page is refreshed or the max age expires. So that could cost you some money. And also you could run into caching issues, like if the data is too stale. So another way we can do this is basically just keep it the old way of letting the server always send new data when it's requested. But in the pages, we can go to the index and let's comment out the first, or comment out this way of fetching, and now do it this way. So there's a key on the use async data options. So you'll see that we've added this posts thing, the key for the request, and also we added this getCachedData with a key and Nuxt. And what we're returning is the Nuxt payload data or the Nuxt static data. And if both are undefined, it's going to trigger this fetch. But if we do have that data in the Nuxt payload, then it's going to show that data instead. So if I refresh this, I have to save that. If I refresh this page now, you'll see that it's 11:38:43. 11:38:48. So it always gets, on a refresh, it always gets the new data. But if I go to the about page and go back, it's instant again. But it never changes. It always stays 52. And that's also an issue, because if a person is on your app for a long while and they keep navigating back and forth with useNuxt link, they're going to keep seeing this data until they do an actual hard refresh, and then they're only, so that could cause problems. And to solve that and make it more like the server-side caching, let's go back to this. Now we've added a transform, and in the transform we've added a TTL, which basically is how long do we want to use the cache for. So let's make this a little bit longer again so that we can actually see it happen. So let's do 10 seconds. And then in cache data, we get the cached stuff. If there's nothing, we trigger a fetch. If the current time is bigger than the TTL that we defined, then we also trigger a refresh with undefined, or we return the cache data. So if I save that and do a hard refresh on this page, if we have a look at the time, it's 40:04. We go back 40:04, and we probably have to do this for a couple of seconds because I made it 10 now. So now you see it lagged a little bit. It took a second because it made a request to the server. And so it's instant for as long as you've defined your TTL, and then it lags and then it goes back. So that's very similar to the server side thing, except we don't get that nice thing where if it refreshes, it still feels instant because it does it in the background. All right, so lastly, if we look at the branches, because I already forgot what I named them, there's something called useNuxtData. And this is a little bit more complicated. So let's do check out useNuxtData. And this is a composable where you can have access to the data that Nuxt already has in its memory. Same way like when we looked at the console by doing __Nuxt, we can do it in code at runtime. So if we go in here and have a look at the changes that I've done. So in API, I've changed the posts to a base post route and an ID post route. So in the base post route, we still have a normal event handler, not cached, that sends the posts back. And then in the ID one, we also have a normal event handler, not cached, that sends a single post back, which just uses that little API that I've set up. So in our page, if we go back to the app pages, we have the index, and then we have a new ID one. So in index, we use that little trick where we do the TTL and the getCachedData, but we add this little helper, which basically says if the refresh is because of a manual refresh by the user, then trigger a refetch, like skip all the cache data. And the rest is the same. We cache it for a certain time and then deep false. Then what we've also done is we've added a link to the post ID, which is this route. And in here we have a thing where we call this useNuxtData composable. The downside of this is that it doesn't automatically type the thing based on the key that we've supplied in useNuxtData, but this posts over here is directly related to this posts over here. So if we use NuxtData and we give it a key of posts, then we know that when we do useNuxtData, we will be able to access that post. So before showing you this way, let me comment out useNuxtData and also comment out all of this. And in these functions, let's comment out all of this. And then let's comment these out too. So now we just have like a single post page. And the reason I'm commenting it out is so that I can show you basically what it does. And I need to restart the server. And then refresh the page. So now you can see the pages have links, and I can still go to about and back home. about back home and do all the regular stuff. We do still have that caching mechanism on the client side. But if I go to post ID, you'll see when I clicked, it took like a second to load this page. And if I go back to posts, it takes like a second to load that page as well. So navigation is quite slow. So we go back to post now, it's cached, so it doesn't have to do that second thing. But every time we go to a new post, it has to basically reload that from the server. And just to remind you, the reason that is because we use async data and then we do a fetch to the server every time. Now, many apps work in a way where you land on a page that has a list of items. And when you click on that item, you go to a specific ID item. And because Nuxt already has that data in memory, what we can do is, instead of fetching that post, we can check if that post is already in the Nuxt data. So we can comment out all of this. And now you can see that we're checking if that exists. I don't have to log that out. And we can find the cached post within the Nuxt data instead of fetching it, if we have a cached post. If we don't, then we do the fetch. So we can basically go back to posts and just refresh this page, because now we already loaded everything. So if I go here, it should be instant. It knows which post we are looking for. So it doesn't have to do the API request. The drawback of this is if you have multiple people that can write to posts, let's say 2 people have this screen open and one person edits it while this person is still on this screen. When they click on this, then they're going to see an outdated post. So you have to take that into consideration. But if it's just a single user and a single session, then this should work fine. If you want to have like a duplicate strategy where you could get the cached post, but instead of, well, you can return it over here, but you can also then fetch it in the background while showing the stale data. And then maybe a second after the data loads, it just updates it on the screen. You could also have a delete and an edit post function that I want to show you. So if we go back to this and then delete this as well. Oops. Save that. So now we are able to delete and edit a post. So the way we do this is called sort of optimistic updating. When a user is on the client and they see this data, so let's refresh this page. They see this for the page. Once I click, let's not redirect quickly. So if I do in the edit post, I'm going to save it like that. So once I click edit over here, you should see that the current title gets updated. Oh yeah, well, we have to go back to here. So because it's not deep, it won't show on this page immediately. But if we edit it over here and go back to the home page, let me just refresh this page completely. So if we go back in here and edit, you'll see that this is now edited. Go back in here, edit, this is edited. If you go back in, you can see it has edited titles. Now it refreshes with fresh data. So what you want to do in reality is, after you've edited in the local data so the user sees it immediately, you want to send your API request to do it on the server. And then if that fails, you have to revert back to your old data. This is very nitpicky stuff. It's not like you always want to do this. You have to first update the Nuxt data state and then send an API request. With something like Pinia, that's trivial because you could just set up a store, have all the web pages, update the web page in the store first, and then do the API request to do like a sort of optimistic update. But once you're working with like a huge data set and you don't want to have a ref on every single item that you basically render out, then you might want to look into these finicky sort of fine-grained tunings to your data. So you might also be thinking that, okay, well, once you edit this page, So let's refresh this. Once you edit the title and you don't want to route back, so this is not routing back anymore. I commented that out. The title is being edited, but it's not showing up here. And that's because we still have a deep false set on the request, which is now the default in Nuxt 4. But if you don't want to have deep reactivity, what you need to do is, in this case, we've defined the data as being the response of the useAsyncData. But what we can do is just say data.value equals the same post again after we've edited the title. So that will trigger Vue to re-render this thing. So now you can already see it there. But if I refresh this and go back to the page, edit, you'll see it immediately updates. And that's just one way that you can make it update, is to replace the entire object instead of just editing a specific key. And then finally, we can remove that and just keep the use router. In delete post, what we can do is basically get the Nuxt data, and that is again from this composable useNuxtData, and we find the index of that post. If it's not -1, so if the post actually exists, we basically splice that entire array with removing that index, and we only remove one item. Then we can do the API request with the actual delete and everything, and we can go back to the home route. So you could, instead of saying await fetch, you could do that in the background maybe before pushing the route. That's up to you. But so let's just demonstrate that. So if I go back to posts and refresh this, so you can see the first one is this long one. If I go in there and say delete, it's gone. And it's gone instantly because we're deleting it from the Nuxt data first. So this is again the optimistic updates. So we've routed back and we've deleted this on the client side. And now we need to wait for the response from the server to confirm whether it's actually deleted. If it wasn't, we have to put it back. If it was deleted successfully, we can just leave it like that. So everything feels a little bit more instant. So if I go back home, I'm going to delete the second one. It feels instant because I've deleted it on the client. And all the waiting stuff could happen on the server. And we just have to make sure that if something goes wrong, we could show a toast. Like when we do a fetch over here, we can say on response error, we could say toast.show failed to delete, and then put that post back there. This does cause sometimes a little bit of UX issues where, let's say for instance, you want to show instant likes on a post. So imagine there was a heart over here and I click it, it instantly highlights, but the request is actually still happening in the background. Then if that fails, then I have to de-highlight this thing again. So the user would look at it and be like, but I just clicked that and now it's back to its old state. So that's why you might want to show a toast to say that, oh, something went wrong, as well as showing like the old state of the thing. So I know this video is a little bit out there and there's a lot of ifs and elses, and it's very nitpicky, and probably you won't do this very regularly, because usually you have pagination where you only load like 24 objects. Then yeah, it's fine to have a deep reactivity on it and just let it update as you change keys. It's fine if a server responds in 100 milliseconds instead of a second. Then clicking something and waiting that 100 milliseconds for it to go away feels kind of instant, you know? So if you are lucky enough to have all those things in place, then you don't need to think about this kind of stuff. But if you're working with an API that is slow, it returns huge amounts of data, and you don't have control over how much it returns, then you can look into these types of things for a little bit of performance improvement. It does add overhead on your end to do all these nitpicky things, but I mean, sometimes you just have to grind out some code. And this helped me in building out like a little table thing, so I thought might as well share it. So if you do like these tips, or if you did like it, leave a comment, let me know. It helps me out knowing what content to make, and if this doesn't do well, then I'm not going to make something like this again. Anyway, remember to like, subscribe if you did, and I'll see you next time.